Right. Hello, everyone, and welcome to the final lecture of Big Data. My continuation of begging to complete the course evaluation, which ends tonight. The next thing is your course project. So I look forward to reviewing your fantastic final projects, which is due in a week. And today, we are going to talk a little bit more about graphs. So the plan for today is, as I posted on Piazza, this will be a bit shorter lecture, hopefully. And then at the end, we'll have time to chat a little bit about the course. I usually do this in my last lecture when I teach a course, and I get really interesting feedback that I do not get from the official course evaluation. So in the past, it helped me a lot to improve this course. Some of the changes I have made to this course is based on the feedback that I got from similar discussions. All right, so the topic of today is graphs again. I'm going to talk about Google's fight with spammers on the internet. It's an interesting topic. So a little bit of a review. So we all of you know PageRank. You have done assignments, so hopefully you know how it works. So this is a technique for assigning importance to different web pages on the internet automatically. And we talked about this numerical approach to solve the problem where we start from an arbitrary score, and then we apply this power iteration technique to solve the problem. We talked about teleports to basically move out of the spider trap and things like that. But I didn't tell you about PageRank problems or limitations, and that's today's topic. So the issue we have is link spam. Our assumption until now has been everybody is behaving well. Nobody is messing with the structure of the links on the internet. And if you remember, the PageRank idea was to look at the structure of links. And that was the idea. So if a page has many incoming links, then we say it probably has a higher score. That's how the algorithm works. So, but if somebody actually creates and manipulates these links in order to mess with the score, what happens? PageRank was not designed to basically protect against such deliberate manipulation of the web graph. The solution is trust rank. We're going to talk about this today. There are some other limitations as well, such as PageRank measures a generic popularity. It doesn't care about the specific topic. It's just the general score. But in some contexts, we need a topic-specific PageRank. For example, we want to find the most trusted pages that talk about sports. How can we do that? That will be done by topic-specific PageRank, which is very similar to personalized PageRank that you already know from the assignment. I have some additional slides at the end of these slides that talk about this topic if you're interested. You already know it, so we can just review it. So, and the final issue is, well, PageRank is one metric. How about other metrics? There are many other metrics. So Google, for example, still uses PageRank, but it's one of the metrics that it uses. They call this signals, different signals. So PageRank is one of the signals that Google uses. So there are many other ones as well. All right, let's talk about trust rank, which is the technique Google uses to combat web spam. So what is web spam? Let's define that before we start this lecture. So basically, spamming is any deliberate action to boost a web page's position in search engine results. Okay, so if you do something to change your ranking in Google's results page, that is spamming. And spam is basically web pages that are the result of spamming. This is a very broad definition, and people in the SEO industry will not agree with us. The SEO is search engine optimization. So there are companies that you pay them to improve your rank on Google. Okay, so they think this is some sort of optimization or engineering, but based on our broad definition, that is also spamming, basically, because that's a deliberate action to boost a page position on Google's page results page. It's approximated that 10 to 15% of web pages are spam. So you know that Google's results page is very important for businesses, and there's a fight to be on the first page because we rarely go to the second page. I've done that in some occasions, and those were really desperate occasions. Okay, that's why I wanted to find something, but I couldn't, so I checked the second page. But we rarely go to the second page. Even we don't. Most of the time we don't click on like fourth or fifth link. It's mostly one of the first links that we click. So for a business, when you search for something like buying shoes, for example, it's very important for a business to rank high. Okay, and that's why we have all of this fight to boost the ranking of a page. Is there any questions? Is everything okay? Say something so that I know I'm still connected to the internet.
No problem.
Thank you. So web search. In order to talk about spamming, we need to talk about, okay, how web search is done, and then how spammers actually try to trick this system. And it's an iterative process. So then the search engines try to improve it, and then they try to somehow win again, and then they update, they change. So it's a basically continuous process that continues until today. So back in the day, like the early versions of search engines were like this. And this lecture is nice because it covers many topics that we talked about in this course. So you are familiar with this. So the basic versions or the early versions of search engines were like this. So you crawl the web, you index pages by the words. So we talked about this. 451 students had an assignment on it, and then we respond to search queries, right? And ranking is basically based on words again. So again, this is before PageRank. Okay, so we talked about ranked retrieval, where and in that case, if you remember, we talked about the importance of a term in a page in order to rank the results for a specific query. The primary metric that we use in this technique is basically number of times a query appears on a page. And also we can incorporate some other fancier techniques, such as also considering the position of the word. For example, if it appears in the title, it's more important than that word appearing somewhere in the text, for example. So you can give it more score. So you're familiar with these techniques. We talked about this. So the first version of the spammers tried to basically trick this technique, right? So how could they exploit search engines? Well, everything was basically based on term frequency, how many times a word appears on a page. So can we mess with this? So, for example, a shirt seller might pretend to be about movies, because movies is a more popular term than shirt. So if a shirt seller website somehow pretends to be about movie, its ranking goes up. So how can that happen? One trick to do this is that website can add the word movie 1,000 times on the page, and then but that looks ugly, right? If it just adds a word so many times on the website. What the trick they do is very simple. They set the color of the text to be the same as the background color so that it's invisible. On some websites, you may notice that there's some empty space in the bottom, and it's actually there. If you actually select, if you drag your mouse, you can select the text and see that, oh, there are some words at the end of the page that you could not see. So that's one of the basic, very basic tricks that they do. And now what happens, because it adds the word movie 1,000 times, the term frequency goes up. So the search engine will be confused. When it looks at this page, it thinks, oh, this page should be a very important page for the term movie because this word appears so many times on this page. So if there is a query that involves movies, I should rank this page high. That's the idea. The other technique, instead of just adding a word many, many times, there's another technique. So you can actually search movie on Google and then find the first link. For example, it might be IMDb, for example. You go to that page, you copy the entire content, you paste it to in your page, and then make it invisible by doing the color techniques. Now, why is this a valid approach? Because, well, whatever content made IMDb #1 for that query, now I have that content on my website as well. So my website should also be ranked very high. So that's another technique that they use. So as you can see, it's basically around term spam. So they try to manipulate the frequency of words on a page in order to be ranked higher. And well, search engine optimization, SEO, does pretty much the same thing, but they don't do exactly what I explained, but they actually add all synonyms of a word. For example, like in this joke, it's like bar, bars, pub, public house. All of them mean the same thing, or they're around the same topic. So they try to add these relevant or equivalent words on a page in order to boost the ranking of that page. So it's the last lecture, so I try to add more memes. What was Google's solution for term spam? Again, these are like what I'm talking about is about like early versions of search engines. I will continue this story to like more modern stuffs, but this was a while ago, right? So this is the first versions. So Google's idea was like this: to say, okay, instead of believing what you say about yourself, I believe what other people say about you, because you can just spam the page by repeating a word many, many, many times. I don't believe you. I believe what others say about you. How? So the idea is to use words in the anchor text. Anchor text is that blue text that you click on. So it's like the text of the link, okay? Or the surrounding text. For example, on another website, it might say, if you're interested in buying shirts, you can visit this page with the link. So when Google looks at that link to that page, it says, and looks at the words around that link, it says it's about selling shirts. So that website should be about shirts, not movies. Okay? And also, Google use PageRank now to find the importance of web pages, so that a crappy page that just repeats some words is not ranked very high. So now PageRank is introduced and you know about it. So in our idea, in our example of the shared seller that just repeats some words many times, it loses because saying he's about movies doesn't help because others don't say he is about movies. And also because of PageRank, his page isn't very important. So it won't be ranked high for shirts or movies. So that's also very nice. Now you may say, okay, how about this shirt seller website also creates like many pages that have a link to his page with the word movie in the anchor text. Sure. What happens? The issue is that those pages don't have many inlinks. So their page rank is very little. So they don't give much a score to the shirt seller website. So in the PageRank algorithm, it's impossible that it can beat a real website such as IMDb in importance. Like IMDb will have a higher PageRank because it has many more valid links from reputable websites. So its PageRank will be much higher than a page that has 1,000 inlinks from pages that have almost no score. This is why it works. Are there any questions? So what we have done, we talked about basic version of search, which is based on rank retrieval that we learned before. Then we talked about how we can, someone can use term spam to mess with the ranking. And then we talk about the solution that involves looking at the anchor text and using PageRank actually to give importance to pages. And that solved the problem for a while, but spammers found another way that I'm going to explain now. But before I move on, is there any question? All right, it looks like there's no question. Very quiet today. So that was why it didn't work, but eventually it worked. Sorry, eventually it failed to work. For example, here you can see that for the query miserable failure, spammers could mess with the PageRank algorithm so that the White House website becomes the #1 result for that query. So this is a real screenshot, okay? So it shows that the technique that I talked about eventually failed, and spammers found a way to mess with PageRank, okay? And what spammers use was a concept called spam farming, okay? So it's like the big data of spamming. So spam farms were developed to basically concentrate PageRank on a single page with the purpose of improving and boosting its ranking. So what I'm going to explain next is basically round 2 of the fight between Google and spammers. We have a new term called link spam. Previously, we had term spam because Google was using term, like term frequency and things like that in like first versions of the search engine. Now it switched to PageRank. So now spammers use link spam. Now they try to mess with the structure of the links in order to break Google's PageRank algorithm. You might have seen pages like this. So their primary focus and purpose is to create link spam. You can see there are many links. So the link spam is technically creating link structures that boost PageRank of a particular page. But how? From a spammer's point of view, there are three types of pages. The first category is inaccessible pages. url.ca. It has no control. It has no access to this website. And there are many, like most web pages are probably like that. Has no access, inaccessible pages. So let's put these aside. A spammer cannot use these websites. The second category is accessible pages. These pages are not owned by the spammer, but the spammer can actually add links to these websites. How? Comments, for example. They can add a link in the comment section of a blog, of a weblog, a YouTube, something like that. So what happens? That would, on the graph of web, it creates a link from, for example, a weblog or YouTube to the target page that the spammer tries to improve the PageRank score of. Okay, so these are not owned by the spammer, but it can add links. Another example is forums. So you can create a profile on a forum, and then you add some links to your profile. And because your profile is a page on that website, you could add links, basically. Okay, so accessible pages, not owned by the spammer, but can be used to add links. And finally, the last category of web pages on the internet are the ones that are actually owned by the spammer. So the spammer actually creates some web pages just for the purpose of adding links to some other websites. Okay. So again, the spammer goal is to maximize the page rank of a target page T. Okay, and the idea is to get as many links from accessible pages like weblogs, YouTube, whatever place that it can add a link, and also construct a link farm. These are the pages that are owned by the spammer to also increase the page rank. So this is a nice overview of what we talked about. So we have these inaccessible pages. We don't care about them. Then we have accessible pages, okay, and we have a target page. The goal is to improve the page rank of this particular node, okay? So on these accessible pages, like weblogs, YouTube, we can add a link to the target page, okay? So it will get some score from these accessible pages, and especially if these are good, reputable websites, that link will be valuable. In addition to these links, there are the pages that owned by the spammer. It can be millions of them. Okay, you may say they won't have much value because they're just crappy websites. Sure, but there are so many of them. Even if they give a little bit of a score to T, it will be multiplied by millions of pages. Okay, and it has some a multiplier effect, because if you think about this, T accumulates the score from these nodes. Agree? So these pages get the scores from the rest of the web, and then they pass some of their score to T, right? Now, what happened here? T, so we can see that here it is like bi-directional links, meaning that this page has a link to this forum page, and that page has a link back to T. So what happens is that we accumulate scores, and then we give this score to these forum pages, but they reflect it back because the only link that they have is back to T. So it's right that T gives its score to these nodes, but they will reflect it back in the next round of PageRank. So we accumulate and then we reflect back. So it creates some sort of multiplier effect on the score. So it's very effective. Let's actually talk a little bit about the actual score, see if we can calculate it. Okay, and here's another meme for now. Links are important, right? So we want to have links to improve our PageRank score. So let's talk about this picture and see if we can calculate the PageRank score using this technique, which is spam farming. Let's assume that the total score that we get from these blue nodes, the accessible pages, is represented by X. So I get like X score from these pages, okay? And Y, the green Y, is the page rank of the target page T. So we want to maximize Y. Okay, now what is the page rank score of these nodes, the red ones? So, well, it's easy. They have only one in-link from T, agree? So their score will be Y, which is the score of this page, divided by M, because T has M outgoing links. So each of them will get 1 over M of that score. You know about this already, page rank. So we also multiply that by beta, which is the jump factor, plus all the score it gets from parachute, from somewhere, like from a page here, we may do a random jump to these nodes. And you know from previous lectures, and that score is 1 minus beta over n, which is the total number of pages on the internet. So that's basically the total score of every red node that's owned by the spammer. Now, let's calculate how much a score this page gets, the target page, which is represented as green Y here. So it's X. So all of the scores I get from the accessible pages, right? Plus, well, I have these many incoming links. So the red nodes will give all of their score to me. All of their score is this much that we calculated before, and there are M of them. So it will be M multiplied by that amount and multiplied by beta, which is the jump factor, plus, again, same thing, 1 minus beta over n, which is the probability that we do a random jump and land on this particular page. Okay, so we can just multiply and simplify here. And then this term, as you can see, this is really small, because it's 1 minus beta over n, which is the number of web pages on the internet. So we can ignore that part. It's really small. And now we can solve this with respect to Y. So Y, which is the page rank score of the target page, will be X. The amount of score it gets from accessible pages divided by 1 minus beta squared plus C times M, the number of farm pages, divided by N, the total number of pages on the internet, divided by a constant C, and C is beta over 1 plus beta. Let's take this term to the next page. So just copy pasted that. So let's talk about this a little bit. This is interesting. Look at this. It is actually multiplied by something. It's multiplied by 1 over 1 minus beta squared, right? If we calculate this, 1 over 1 minus beta squared is actually 3.6 if beta is 0.85. So every link that you have from a weblog or YouTube to that target page will not only get some score from that website, but also it will be multiplied by almost 4. And the reason this happens is because of this thing that we created here, that we get the score and we don't really give it to anyone. We give it to these farm pages and they give it back to me, right? So that's why it multiplies the effect. And now, so I got some scores from accessible pages, right? That's part of my score, right? And then I also have this part. So if it's not enough, I can increase M, the number of farm pages, so that we get the score that I wanted. Because this is a linear, basically, relationship. So it's M over N. So if I want to double the score I get from the farm pages, I just double the number of pages that I have. Make sense? So that's basically the structure of this. So some score is coming from accessible pages. It has this multiplier effect because of the way it's constructed, and also we get the scores from farm pages. And if we have enough farm pages, like millions of them, it can impact the performance of PageRank enough that it can completely change the ranking of a website on Google. And the spammers have been using something like this for years. Okay, you must have some questions now. Everyone happy, or there are some questions? You're so silent today. Everything is okay? All right. Let's move on. So this is a problem for Google now, because there is a way to break PageRank, basically. So how can we combat web spam? And let's talk about this algorithm, TrustRank. So in general, there are two types of spamming. We have term spam and we have link spam. So term spam, as you know, is just adding some words to a web page so that it messes the term frequency. Modern solutions for fighting against this is using basically statistical models. Because if you remember, we talked about this, that term frequency follows a Zipf's distribution. So we know, we have a good idea of how many times a word should be repeated in a text. We have a good idea, we have a model for it. So if we apply that model to a web page and we realize that some words are appearing many more times than normal, that's a red flag that maybe they are doing this on purpose and they're just repeating those words in order to improve the importance of that page for those keywords. So there are techniques like that to fight basically spam. It's similar to email spam filtering. And then let's talk about link spam. This is the new problem that I introduced in the previous slide. So it's basically it's a process of detecting and blacklisting structures that look like spam forms, which leads to another war. How can we hide and detect the spam forms? It's ongoing, right? Google has upgraded its detection system multiple times over the last 10 years in order to fight against the spam forms. It's interesting. It also messes the SEO industry, because every time Google changes its algorithm or updates its algorithm, a page that was previously ranked high can go down, and the SEO clients will be unhappy about it. So the solution to this problem is something called TrustRank, which is a topic-specific PageRank. At a very high level, you already know this. Topic-specific PageRank is like personalized PageRank, but those source nodes are special nodes. So you know about personalized PageRank. So it's a PageRank, but whenever we jump back to a set of source nodes. We don't randomly jump to any page. We go back to one of the source nodes, one or multiple source nodes that we have. Okay, so that's personalized PageRank. What is topic-specific PageRank? Those specific pages, sorry, those source nodes are specific pages. what I have to talk about, what those are. But that's a high level idea. So we want to basically fight link spam, and let's see how we can do this using this algorithm. So the idea, I think the whole idea is around this. It is rare for a good page to point to a bad page. What is the probability that uwarlu.ca website has a link to a spam page? Almost impossible. We can say the probability is 0. That's the whole idea. So the idea in trust rank is let's always start from a reputable page. And this set of pages are called seed pages. Okay, so we need an oracle, which is a human basically, to identify the good pages and the spam pages in the seed set. Okay, so we start with the seed set. Not all of them are not good. Maybe I was not very accurate in my definition. So we have a seed set. It includes good and bad pages. Someone should review these pages to identify good pages. Okay, as you can imagine, because it's a supervised technique that requires human involvement. It's a bottleneck. So we want the seed set to be as small as possible. And then we call the subset of seed pages that are identified as good trusted pages. So we call them trusted pages. These will be our source nodes in the personalized PageRank or topic sensitive PageRank. And then we basically propagate trust the same way that we were propagating scores in PageRank. We are now propagating trust. Okay. And if a page gets a high trust score, we say we can trust this one. If it has a trust score lower than a threshold, we say this is a spam page. Simple. The mechanism is pretty much like PageRank. So what I have here is just for your reference. You know about this. For example, every page has some outgoing links. So it basically divides its score, or in this case, trust, equally amongst its outgoing links, and it gives some part of its score to those neighbors. And the beauty of this technique is that trust is additive. So if I have a node, if I get some score from one of those good pages, I can also get score from some other good pages. So it's nice. It will boost my trust score if this is really a good page. And again, another note that this is very similar to personalized PageRank. And why is this a good idea? Because of trust attenuation and trust splitting. What does that mean? So if I have a good website like uwarlu.ca, then its neighbor will get a high trust score. Agree? Because it's so close to it. You know that in PageRank, if you're close to one of those personalized, if you're close to one of the source nodes in the personalized PageRank, you get a very high score. Because every time we start from this node is a probability that we land at this page, so it increases our score. And then that page can have a link to another page, right? And that one still has a decent score. But if a page is very far, so that links to another page, links to another page, links to another page. If it's very far, this guy won't get much trust because trust attenuates. So as you move away from the good nodes, you won't get much trust. And that's a property of PageRank. You're already familiar with this. And we have also trust splitting. Again, you know about this. So if a page, a good page, for example, has many outgoing links, that would reduce the amount of trust we give to these pages, right? Compared to a good page that has, for example, only one neighbor, right? So if we split the trust to many pages, then those pages don't get much trust, and that's a good idea. Now, how can we pick the seed set? There are two conflicting considerations here. One is because it's a human involved process, we want the seed page to be as small as possible because that's a bottleneck. How many pages can we investigate? On the other hand, we must ensure every good page gets adequate trust rank. So if you don't have many good pages in your seed set, it's possible that there are some good pages that are far from those few nodes and they don't get enough score and they are ranked as a spam. While they're not spam, they're just far from those good pages. Okay, so we want to have many good pages to start with. There are two tricks to solve this issue. One is you can run normal PageRank on the web graph, and then you pick top K pages by PageRank. The idea here is that even if you have spam pages, it's very unlikely that they show up on the top K pages because those are legit pages. Their score is really high. It's almost impossible to get to those very high scores by doing any type of artificial manipulation in the graph. Okay, so you can use those top K pages as your starting points, as your good pages. The other trick that you can use is that there are some domains such as .edu, .mil, .gov that are not publicly accessible. You cannot just go ahead and register a like .edu website. You cannot. It's not like a .com or .net website. Okay, it's there's restriction on who can register those type of domains. So because there is some monitoring over those domains, uh, you can trust those as well. So that's another technique to add to your good pages. So we can say anything that ends with .edu, I trust those pages. These are university web pages. So without actually having somebody manually inspect all of those, we can say all of them are good. So we can increase the number of good pages in our seed set. All right, and the last thing I want to talk about is well, it's just a different view of what I explained. So in what I explained, I said, okay, we start from some good pages, and then we propagate trust to other nodes, and then we have a threshold. If this page trust score is higher than the threshold, it's a good page. Otherwise, it's a spam page. A slightly different view of the same problems, a different angle of looking at the problem is what fraction of a page's page rank comes from spam pages? That's another way you can model it, right? Instead of looking at the absolute trust score, you can calculate like what fraction of its score is coming from spam pages. So if it's a legit page, almost 0% of its score is coming from spam pages. If it's a page that was the target of spam farming, then most of its score, a lot of its score is coming from spam pages. So that can also be a metric for distinguishing good pages from spam pages. But in practice, we don't know all of the spam pages. So we need to estimate it. So the second way, instead of looking at the absolute trust score, you can look at basically what fraction of the score is coming from spam pages. And this is actually pretty simple. So in order to calculate it, first you calculate the regular PageRank score of a page like this. We're talking about this page. We don't know what fraction of its score is coming from spam pages, and we want to estimate that. So first we calculate the probability or the rank using the regular PageRank algorithm. Forget about trust set, all of that. All nodes are the same. We run regular PageRank. It gets a score. We call that R sub P. Then we run PageRank, but we teleport to some trusted set. like what we just talked about. So this is like personalized page rank, and they have a bunch of trusted set. Whenever we jump, we go back to these one of these nodes randomly, not everywhere on the graph. We call that R sub p plus. Okay, so this is basically the trust or the score this particular page gets when we start only from our trusted set. And now we can actually calculate the fraction of a page uh, score, a page's score from spam pages, and that we represent that as R sub p minus. So it's regular PageRank score minus the score it gets when we have a set of trusted nodes. So the idea is if this is a spam page, this will be a positive number because in the regular PageRank algorithm, it gets some score because all of those form pages give it some score, right? But in the trusted version, it in theory it's far from these nodes, so it should not get much score. So this will be smaller than this, and as a result, when we subtract it, this R sub p minus will be a positive number. So and we calculate the spam mass, which is basically this RP minus over RP, the regular PageRank score. If this ratio is high, it means that this is a spam page. If the ratio is low, then it's a good page. So as you can see, it's just another metric that we can use instead of using absolute trust score, which might be a little bit more robust compared to the previous technique that I talked about. Any questions? If there's no question, this is the end of big data lectures. Let me know if you have any questions. I have a few more slides about the course. So let's wrap up. So some stats. Uh, this is the end of this story, and hopefully it's the beginning of many stories for you. And I wish you success in what comes next in your internship or your next jobs. You will find what we learned in this course very useful if your job is relevant to this course. I usually get letters from students, from former students, just appreciating how much what they learned in this course helped them in their job. And again, there's a ton of hype around these topics, okay? So we talked about this before. Think about this seriously. Is this really what you like, or you follow the trend? If you follow the trend, think about what you really like and follow your dreams. Thank you for attending live lectures and asking questions, keeping the lectures a bit more interacting. Hopefully next time we will be in a classroom and we get more interaction. And also thank you for following up the lectures on YouTube. Every lecture was viewed like 200 or 300 times, which is a lot considering that we have around 200, less than 200 students across all sections. And thanks for working on the assignment. Unfortunately, there is a small group of cheaters that I will contact soon, despite warning many times that if you cheat, we will find it. Some students decided to cheat. If you haven't cheated, there's no reason to worry about. And I will contact those suspicious submissions very soon. Unfortunately, there were many cases, and I had to spend the last few weeks on figuring out what's going on. But I thank those of you who honestly work on the assignments, and I guarantee it will help you a ton in the future. So we had two Piazza pages, 451 and 431. Based on what Piazza reports, our average response time was around 1 hour. That's the average. There are cases that's much longer, which is really good, especially for this course, because it's not like introduction to programming that you share code and uh, I immediately see that, yeah, you're missing a semicolon. It's not like that. It's really complex, and sometimes TAs cannot figure it out. I have to look at it. Sometimes take us like hours try to figure out what's wrong. Despite that, I think overall we had an acceptable uh, response time, but this is something that you guys need to confirm. Write it in the course evaluation or talk about this in the discussion that we will have. Some stats. So my TAs and I responded to 1,700 questions. So these are the number of responses. We might have multiple responses to the same question. So 1,700 answers. And for 431, we had around 400 answers. This is pretty much in line with the number of students we have in these courses. I have a meme for stats on Piazza. Sure, I have a meme for anything. So there you go. All right, that's really the end. I have some additional slides if you want to read more about topic specific PageRank, but other than that, there's nothing else. Thanks so much. And if you have any questions, we keep recording a little bit longer. Otherwise, we stop recording and we just open the floor to an informal discussion about this course. All right, I don't see any questions. So I'm going to stop recording and we start our discussion next. Okay, so goodbye to the people of YouTube. We wish you were here to talk about the course, but for some reason you could not make it. So best of luck.